dear student, today we'll discuss calculus. This is one of the trial exam question for Negeri Sembilan. Question number 4 is involving calculus because this topic actually you need to use differentiation and also integration at the same time. For differentiation is something to do with the gradient of the curve, and then for the differentiation is gradient of the curve, and for integration is the area and the volume. Okay, volume. So let's get started with reading the question. Diagram 2 shows a straight line y plus x equal to 6 intersects. The moment you see intersects, you need to find point of intersection by using simultaneous equation. So we have two, one is a straight line, the other one is a curve. So we will sub the straight line, y is 6 minus x, into the curve, which is y square. So when we see y square minus equal to 2x minus 4, we will sub 1 into 2. So when we see y, we will substitute 6 minus x squared equal to 2x minus 4. And then we will try to solve the quadratic equation, which is equal to 2x minus 4. So x squared minus 14x minus 40 equal to 0. If we factorize, we will get two answers, which is 10 and 4. So the x is equal to 4, x is equal to 10. So in this case, we will choose the logic point for p should be 4x. Actually, there is another point here whereby the x is 10, right? Here should be 10. So we will reject this point because it's not the point that we are look forward to use it. So when you have the x, you have to find the y. Either we use a straight line, so we substitute into this one, y equal to 6 minus x, 6 minus 4, which is 2. So this is a point P. And then we are asking to shade the region bounded by the curve, straight line, and also both axes. So let's try to shade the curve. Okay, this is the curve. This is the x-axis, this is the y-axis, and this is a straight line. So this is the area wanted by the question. So now we need to calculate the area, right? Hence, for the shaded region, we have to find the area of the shaded region. Now, in order to find the area for the shaded region, we can actually divide the curve into two sides, which is A and B. So area for A is actually, this is a triangle, right? So we have the 6 here. This is 2. Look at the y. Okay, y plus x equal to 6. So x 0, y 6. So that means we will use 1 over 2. We'll take the base here 4, and then we times the height here 4. So we have 2 times 4, which is 8. Alright, so after that, we will find the area under the curve, which is this one. Okay, so this part is under the curve. So the curve, we can use the y boundary, which is easier. If we use the x boundary, we will have to find the trapezium, which is a bit troublesome. So I will prefer to use integrate dy for x. Alright, so because the boundary I use is a y, so I'm going to write x as y squared plus 4 divided by 2, or I can write y squared over 2 plus 2. So let's find the easy way. And because it's bounded by y-axis, so the limit should follow the y-axis 0 to 2, and the x is y squared over 2 plus with the 2. Then we will integrate. So this is y power 3 over 6, okay, plus 2y, and then we'll integrate from 0 to 2. So the answer is 8 over 6 plus if we substitute, we will get 8. 2 times 2 will be 4. So the area is 24. 24 plus 8, 32 over 6, or we will get 16 over 3, right? Then we need to plus with the area of the triangle, which is 8. So the total area will be, the area for triangle is 1 over 2. The 4 is a base and the height is 4, so it's 8. So 8 we will plus with the 16 over 3, so A plus B. The total area is 8 plus 16 over 3. So we have 24 over 3 plus 16 over 3. So we will get the answer for the area, which is 40 over 3 units square. Right, so this is the area for the region bounded by the curve, the both axes and the straight line. So then followed by we'll calculate the volume. Volume generated when the region is revolved about the y-axis. The region meaning that we are using the same area. So if we try to rotate this area about the y-axis, so what we will get is the shape which looks like this. You will expect a cone. Okay, the base area for the cone is a circle, 1/3 pi. R will be 4 square times with the height will be 4. This is a height, 6 minus 2. So we will have 64 over 3 pi. And then for the volume for the other one, for this one, let's highlight using the green one. Okay, so let's focus to this area. Let's say I want to focus to this area. This area is going to rotate about the y-axis. So the volume generated will look like this. It is the shape like this, right? Okay, so in this case, we have to integrate by using x squared dy. Okay, x squared dy, because it's bounded by the y-axis. So again, the formula will be x squared dy, and the limit is 0 to 2. 0 to 2. So then we will convert the x is y squared plus 4. That means x is y squared plus 4 over 2. So we need to square it so before we can integrate. So volume for the blue one is pi. Integrate from 0 to 2. Y squared plus 4 divided by 2. And we need to square it before we integrate. So let's try to solve it. Volume is pi. Integrate 0 to 2, y4, y squared times y squared, y4. 2 times 4 will be 8, y squared plus 4 squared, 16 over 4 dy. So let's try to simplify. The 4 we can do this way. 0 2y4 over 4 plus 2y squared plus 4 dy. Then we will have to integrate the volume pi y5 over 20 plus 2y3 over 3 plus 4y, and we sub from 0 to 2. So let's try to simplify. So volume will be pi, and then we substitute the 2 will be 32 over 20 plus 2 times 8 over 3 plus 4 times 2 minus 0. Then we will try to get the simplest answer is 16. Okay, we divide by 4, 5, 16 over 3 plus 8. So then we will try to make the denominator the same. We times with the 3, times with the 3, times with the 5, times with the 5, times with the 15, times with the 15. So finally we get 24 over 15 plus 80 over 15 plus 120 over 15. So the answer for the volume is 224 pi over 15. Alright, so we need to join the combined volume. Just now we have the volume for the cone, 64 over 3 pi, right? So the total volume total is 64 over 3 pi plus with the 224 pi over 15. So we have to multiply by 5 here, multiply by 5 here. So the total volume is 320 over 15 pi plus 224 over 15 pi. So finally our answer is for the volume is equal to 544 over 15 pi, or you can write the answer which is equivalent to 36 4 over 15 pi, or maybe you can give the answer in terms of 4 significant figure 36.27 pi. The answer must be in terms of pi. So that's all my sharing on how to solve the question involving calculus to solve the area and the volume. Till then, bye bye and have a nice day.